All right, so we're going to talk about Nscale, the company that employs me at the moment. We are a new hyperscaler or a neo cloud. There are different names for that these days. The unique value proposition that we offer is essentially we're an end-to-end vertically integrated AI stack from the ground to the cloud, which sounds very cool. I'm going to talk mainly about in this slide about the DC construction kind of part, and then in the other slides I'll cover the other parts as well. The resolution could be better. Now, what we do offer is a unique service where we customize the data center for the customers. We work with them, it could be including identifying a location, but if they have an existing one, we kind of work with that. And then we build up a data center that is essentially unique to what they want, which allows customization, optimization of different workloads. Think about it as a hyperscaler approach to private cloud. I think that kind of sums it up. Now, you might have heard about us in the news. We're kind of working among some of our customers. OpenAI and Microsoft are probably kind of the biggest ones, that with 200 and 100 GPU clusters there. We had recently a Series B, which was the largest in Europe, and then a SAFC as well, following that one. We're also building the largest supercompute cluster with Microsoft in Europe, which is about 23,000 nodes as well. And it's really kind of an interesting time where there's this kind of a convergence. And for those who've been around, we have, native cloud or cloud native, and now there's this emerging AI native or AI first approaches, and kind of going to talk about that in a second. So why is the cloud is kind of nicely fits into that paradigm or supports that paradigm? It's essentially based on the diversity, and we have different types of diversity. We have diversity of different workloads, where model training, fine-tuning, inference, all of them have slightly different parameters. You optimize throughput versus latency versus end-to-end time. There's actually quite a lot of diversity of AI and ML libraries, which kind of fit nicely into kind of the container type of solutions. You obviously have diversity in the different platforms, Kubernetes, Slurm, virtual machine, or customers that actually want to run on bare metal as well. And then, of course, how people consume those services and how they scale them, whether kind of from a single node, single VM to a whole fleet or a whole cluster, or a cluster of clusters as well. On the other hand, with HPC, it's been around for a while, and this is kind of where we started realizing, hey, a lot of the problems that are solved in HPC are essentially quite relevant for AI as well, especially if you're doing large-scale pre-training or tuning kind of workloads. And it's about essentially how do you tap into the massive compute that everyone may need. How do you then leverage the most efficient bandwidth approaches or get the lowest latency out of your network? Then obviously AI is extremely intensive, data intensive. So how do you actually translate that into managing those workloads? And of course, nothing comes for free, especially when it comes to power and efficiency. And this is where a lot of the actual bottlenecks are. So how do you actually optimize that in terms of cooling, redundancy, and efficiencies? The convergence across those two is essentially kind of bringing cloud and HPC solutions to AI. That's really kind of the heart of it, and how do you actually make them work together? So, and this is where, for instance, we're applying cloud native approaches to bare metal, which is to some extent one of the reasons people went away from them. So we're essentially offering bare metal as a service as one of our offerings. The other approach is around kind of automation, that came from managing large HPC environments, but then we applied to even the smaller scale to be able to achieve and optimize your performance and throughput. And then on top of that, we essentially embrace the Kubernetes and the Slurm for those environments and provide those as offerings on our platform, and allows them kind of just focus on making those things work, or to train the model rather than setting up those complicated clusters and manage them. So we provide those offerings as well. So I've kind of mentioned some of the things, but kind of from a data center perspective upwards, we have the infrastructure, which is compute, network, storage. All are optimized, and obviously kind of power as well. All are optimized based on customer specifications, customers' needs. and we've built some kind of proprietary technology to kind of manage all those different workloads in terms of kind of scale up management, observability, etc., etc. As you go up the stack towards the orchestration of multi-compute workloads, as I said, we embrace Slurm and Kubernetes, but then we have our own kind of proprietary solution to manage those workloads, to scale them, and we're kind of part of the open source kind of a community, in driving, pushing the open source forward for them as well. But some of the things we kind of leverage today are kind of Argo, Cilium, virtual clusters, Kubernetes, and those are some of the services. So managed Slurm, managed Kubernetes, and bare metal. Those are the three kind of base orchestration kind of capabilities. As we go up the stack, so this is kind of more the end consumer. What we're trying to actually position is competitive services to Hyperscaler. So if you want to do it first as a service, you can. We provide essentially an open AI API compatible interface that you can scale and load the open source models or your proprietary models. You can then also fine-tune existing models using our services and get them deployed. And obviously, as part of that experience, you can evaluate how they perform based on your metrics, based on those kind of capabilities. Behind the scenes, we're using PyTorch, Docker, and VLLM quite a bit. And obviously, depending on your requirements, NVIDIA versus AMD, we can support both as well. So in terms of kind of, I'll start wrapping this up. So as we think about the future, kind of what are the things that we as a company want to do? So essentially kind of focus on global fleet management. And this is where some of the enterprises today need to deal with three different suppliers. Like, you have AWS, you have your local on-prem private cloud, but we actually want to offer global, whether it's your local on-prem solutions that we work with you, or your public private cloud solutions. We want to give that global fleet management solutions that you as a customer can have a consistent experience there. Then we can also looking at the more logistics and kind of supply chain side of things as well. So how do we actually bring all that software space into this modern age so that it will work with the scale and complexity of those environments. We do want to diversify further our AI services, so kind of working more with open source systems, and then kind of start bringing some of those kind of more mature enterprise features around management of resources and policies, so the customers can actually define fine-grained access controls and things like that we see with more mature hyperscalers. We already started supporting some of the local EU model builders, but there'll be some additional kind of announcements on that later. And in general, we do support the open source and the model builder community through our Hugging Face. So we're one of the Hugging Face inference providers as well. We build a lot of software tools, so this is kind of more if you're kind of interested in working for us, come to our booth, let's have a chat. So building a tool chain or building with AI, so we have a presentation there soon enough. It's 6351 in 3 p.m. Come to us. Different HPC optimization for fine-tuning, and as I mentioned, integration with different OSS providers, leading OSS provider for fine-tuning, evals, and whatnot.